Do you smell that? That's Mimi cooking up another lesson in AP Statistics. Let's get into it.
I hated that. We're just going to keep going. Okay. Let's start. There we go.
Wait, are you going to use that?
Yeah, I'm going to use that. Unfortunately. Okay, that took up 30 seconds.
30 seconds.
Okay. All right, so definitions. Last class, we talked all about sampling design. Those were all specified towards a observational study. So first PowerPoint is in the window or the column of observational studies. And that is when you are only observing outcomes and you're without imposing any treatments. So when you're doing an observational study, you have to use one of the sampling methods that we talked about last class. So SRS, stratified, systematic, cluster, one of those four. So with observational study, you sample to get your sample, and it must be random, things like that. So that was all last PowerPoint. Today, we're going to talk about experimental design or experiments. That's when you are actively imposing some treatment in order to observe the response. So you don't use the sampling methods we talked about for that. You are randomly assigning. So you randomly assign subjects, subjects to treatments. And we're going to talk about ways that you can do that. There are 3 different ways you can randomly assign subjects to treatments. So first PowerPoint, think about that as all observational stuff. That just means you're kind of sitting and you're watching what happens, but you're not making anyone do anything. With an experiment, you're imposing some sort of treatment. So maybe I think that how much you study affects what you make on a test. So I'm going to split you in half, and I'm going to make half of you, or I'm going to assign half of you to study 4 hours, and I'm going to assign the other half of you to not study at all. And so when doing that, that means that I'm imposing a treatment, means I'm making you do something, and then I'm going to gather the results and compare the groups. So that would be an example of an experiment. Whereas an observational study would be, I'm going to let you all study the amounts that you want to. I'm not going to make you do anything, and then we're going to come back and I'm going to gather the data, and I'm going to decide if that affects it or not. A survey is simply asking respondents for data, no observation or treatments. So this is where it gets really weird. I'm not gonna lie. This is like the weirdest PowerPoint I've ever seen, but it gets the job done. So I developed a new rabbit food, Hippity Hop.
Oh no.
Makes fur soft and shiny. Increases energy. 100% of daily vitamins and essential oils.
100%.
100%.
All vitamins are
For the rabbits. For the rabbits.
Still good.
Can I just make these claims?
No.
No, obviously not.
I mean, you could.
100% of daily vitamins. We got to back it up. That's right. I got to do an experiment to make these claims because now I'm going to learn that we can say the word causes and it's going to be okay. I know. By doing an experiment, we can now use the word causes. So, who or what should I test this on?
Bunnies.
Bunnies or rabbits.
Are
And what do I
bunnies
test?
What do I test?
If it makes the fur soft and shiny.
Yeah, so I'm gonna test the type of
Take a
food.
blood test and see how many vitamins are in.
So I could give them the Hippity Hop food, and then I could give them the food that they've been given, their whole lives. What do rabbits eat?
I put mine carrots and hay.
You have a rabbit?
No, I used to.
Oh,
I remember.
rest
the
in
day
peace.
This one, no. You know who has 2 rabbits?
Who?
Alex Donaldson.
Of course he does.
I vividly remember that day. I thought it was about me.
So an experimental unit is the individual to which different treatments are assigned. So experimental units are the who. Like who are the people or the thing or the object that gets the treatment. And so this seems very self-explanatory and it seems like it makes sense, but you have to ask yourself the question, who or what is getting the treatment? because it's not always a person or a rabbit or a thing. It could be, like we'll see in the fertilizer activity, it could be a plot of land. So you have to think about who or what is getting the treatment. So who/what gets treatment. That is the question that you ask yourself. A factor, that is the explanatory variable, which is your x. That is what we are testing. So our x variable, that is what we are testing. We call that a factor. So a lot of times on a free response, they'll give you a scenario, or even on multiple choice questions, they'll give you a scenario and they'll say, what is the factor? What is the experimental unit? And things like that. So you have to be able to read this really long, daunting paragraph about hippity hop rabbit food and all of that. I mean, it's like long paragraphs on these multiple choice questions. And then you have to be able to pick out these types of things. So this test will be a lot of reading, a lot of like big chunks of paragraphs. And then a level is a specific value for the factor. So let's say my factor is the type of food, and maybe I have 3 different types of food that I want to test on the rabbit. So I've made 3 different types of hippity hop foods. Then I would have 3 levels within that factor. So it's like you have factor above. I'm going to go back. You have your factor, which is kind of like the umbrella. And then within that, you have levels. So you could have level 1, level 2, level 3. So level is under the factors. Your response variable, that is what you are measuring. Remember, response is your y. And so my suggestion when you're doing this is to think about, if I were to put this on a scatter plot or something, what would my x variable be? What would my y? So y is kind of like your end result. It's what you're measuring at the end of the experiment. So at the end, what are you collecting? What are you measuring at the end? So maybe with this hippity hop food, I guess we'll find out what it's going to be, but you could measure their, I guess, supplement intake, or maybe their health. I don't know what you measure on a rabbit.
Put them on a wheel.
Their heart rate, the amount of vitamins in their body, the proportion of essential oils and vitamins consumed.
They're vertical.
They're vertical hop.
They're vertical hop, yes.
Vertical thing.
The treatment, some more vocab. Treatment is a specific experimental condition applied to the unit. So the treatment is like what is actually getting applied to the experimental units. So the treatment in this case would be the type of food being fed, yes. So I plan to test my new rabbit food. What are my experimental units? The rabbits. My factor is the type of food. And I guess we have found out that we're going to measure how well they grow. So we can measure their height and weight, something like that. And so response variable is like the data that you're collecting at the end. So after I've given them the treatments, after I've fed them the types of food that I am trying to test, then I'm going to measure how well they grow. I'll use my pet rabbit, Lucky. Since Lucky's coat is shinier and he has more energy, then Hippity Hop is a better rabbit food. So we have what we call a control group, and in most cases, so in most experiments, you do need a control group. And the reason being for a control group means like I'm not changing anything for that specific experimental unit. Like I'm keeping them constant. So I need a rabbit that doesn't change the food that they take or the food that they eat, because otherwise if I fed every single bunny the new type of food, I have nothing to compare it back to. So you need a control group, because when you do the experimental group, when you feed them the hippity hop food, I need something to compare it to. So how well would the rabbit regularly grow with normal food, and how well does the hippity hop bunny or rabbit to grow. And then I compare the differences between the two. So a control group is a group that is used to compare the factor against. It can be a placebo. Placebo just means that we're tricking people into thinking that they're getting a treatment, but they're really not, like a sugar pill or something.
Is that what
Grey's
the happy
Anatomy,
pill?
they start acting
Yeah.
like they were doing whatever. They feel like they're being
Yeah.
treated, but they're not.
A placebo could be like, maybe I'm gonna give you this.
You tell the rabbit.
I think
"This
everyone
will
is
make your
here.
fur shiny and
Yeah.
ooh, look at this.
No, he's not. So like a placebo could be, maybe I advertise this new like study supplement, and I tell you that when you take this study supplement that is completely full of vitamins and not drugs, it's just vitamins. It's no, not drugs, just vitamins, and it's gonna help you study. I could give half of the class the actual supplement, and then I could give the other class just a placebo. But you think that you're getting this supplement so you actually study a lot better. And I've seen this on like weight loss experiments and things like that, where they give you a weight loss pill and then people get a placebo and they start losing weight because they think they're getting this pill that's
Wait, how does
helping
that
them.
work? Your body physically responds, or like
Your brain. So your brain
losing
subconsciously thinks, I'm taking this pill that's supposed to make me lose
So-
weight, so I'm going to start like eating better and
Oh.
working out to compensate
that.
with that, and then you start losing weight anyway.
wow.
It's all in your brain. So that's kind of what a placebo
I'm
is.
thinking I'm gonna get an A+.
Say,
Yes.
bunny, you're gonna have shiny
So
ashes first.
with a control group, it is not necessary. So you're going to see some experiments that don't have a control group. I don't think that's the wisest decision. I would say in most experiments there are one. But if you got a question, because you know that one of those will show up that says you always need a control group, then that would be a false statement. So it is not necessary. However, it is recommended. A placebo is a dummy treatment that can have no physical effect. So we kind of already talked about that. It could be in the form of like a sugar pill, or that's really the only types of placebos that I've seen are in sort of like pills or supplements or something, or
I just
vitamins.
like to make sure that you're not getting like these results because people just think.
Right.
Okay.
Right. So we want to make sure that it's actually the weight loss supplement, and it's not because people think that because they're getting a pill they're going to lose weight. Right. And that's called the placebo effect, when people are losing weight because they're taking a placebo, but they think that they're, actually losing weight because of that. So now I'll use Lucky and my friend's rabbit, Flash.
We need to name it. We should name one Gravy.
It's this lady named Kathy Fritz. I hope she watches this video. She's like a stats guru. Hello.
I think I left my binder over here.
You did. It's on my desk. So now I'll use Lucky and my friend's rabbit, Flash. Lucky gets hippity hop food, and Flash gets the old rabbit food. And look how little Flash
Wow.
is compared to Lucky. Wow, Lucky is bigger and shinier, so hippity hop is better. It's still not. We're still not there. Like, it's still not right. We need to do other
You
things.
need to change the name to Opus.
Now I have more bunnies. Is everyone watching what's happening here?
Yes.
Because one bunny was not enough per food. You can't just have one bunny per food.
Per food. For one pellet of food.
You can't.
You're about to get one.
You can't. We need to replicate these bunnies.
Wait, are you killing them?
Bunnies replicate.
No.
Bunnies reproduce like bunnies.
We need more bunnies. More bunnies, the better. That's what we need.
That is a-
So the first 5 rabbits that I catch will get hippity hop food. 1, 2, 3, 4, 5.
Oh, you caught him.
And then the next 5 are gonna go to
What-
the old
what if
food.
they have,
see a trend.
Genetic disease or something,
A
and
rabies.
so they react differently to the food and others.
I don't
That's why
know.
you take
The hippity hop rabbits have scored higher, so it's better food. Do you see any other issues with this?
Yes, what I just said.
What'd you say, Brooks? I didn't hear you. I'm sorry. No, I want to hear what you said.
They could have like some like genetic issue with like.
They could. Do you look at the sizes in the hippity hops versus the sizes in the old food?
They take steroids.
They could be taking steroids. That could be it too.
Performance
You know,
enhancing drugs.
Did we have any sort of randomness in
No, you
this?
just picked the first
No,
one.
We just- Yeah.
That's convenience.
Yeah.
You just
So
some random
here's
numbers.
how I should randomize this, and this is kind of like the answer key that I did, but we're going to get more into this in the next unit, so don't worry about it, but just watch it and take it all in for right now. So instead, if I want to randomly assign these bunny rabbits to the two groups, I'm going to number them from 1 to 10. I'm going to put the numbers 1 through 10 in a hat,
We're in your
because
way.
that's the easiest way to do it. It's
Everyone
so
has a top hat with them.
using the hat method on the AP test is a foolproof way that you will never.
Everyone has a top hat. That's
Everyone
fine.
has a hat.
You've got to have your magic top hat.
So the first 5 numbers pulled from the hat will be the rabbits that go to Hippity Hop.
Or are they gonna pull the rabbits out of the hat?
Rabbits?
No, the rabbits don't go in the hat.
Just made that joke, Jeremy. Oh no.
The remaining rabbits go to the old food. Now we've got a little mixture of both.
Chunky rabbit. That left side is way bigger.
Yeah.
So-
Number 4 has really random you to judge its weight.
So, but it was randomized. It was random, so it's okay. It's okay now that it's random. So I evaluated the rabbits and found the rabbits eating Hippity Hop are better than the old food. But now that is a legit claim. So the next vocab term is called blinding. Blinding is a method used so that the units don't know which treatment they are getting. So blinding could be like, I'm doing an experiment on you right now and you don't know what treatment group you're in.
What?
What is treatment group? Like what we're receiving?
Yeah.
You don't know what you're doing to
Yeah,
us?
like what if I
there could be something like
I could be doing something right now.
You're not doing
No, a
anything.
favor
I could
that's-
be.
You don't
You know
think
those
I'm
cookies I
right.
fed you?
Oh my god! Ah! I didn't even, Courtney almost got my white.
Oh.
I know Mimi would never do that.
Mimi might do it. You never know. So, yes. So blinding means the experimental units, the people getting the treatments, don't know what group they're in. And a lot of times you need blinding because if you knew what treatment group you were in, that would affect your results. So if you knew that you were in the group that got the weight loss treatment, then you'd probably lose weight more than the people that didn't get it. Or if you knew you were in the placebo group, that would ruin everything. So you don't want to know what group you're in. So that's called blinding. Double blind. Double blind would be the person that is administering the experiment and the experimental units both don't know. So that would be like,
How do you find the result?
no, so that would be like, for instance, that would be like Mrs. Morris is doing an experiment on all of us, and I'm administering the experiment, but I don't know what group this is, and then, so it could be like, maybe
So
on,
yours doesn't affect how we.
yeah, like maybe on PSAT day or something, everyone's in these rooms, and then
take
the people taking the PSAT could be getting an experiment, and then I'm giving the PSAT, but I don't know what treatment group I'm in. Maybe they're, I've seen an example maybe on homework or something where it was like the temperature in the classroom affects how well you do on a test. So like, if if it's colder, then you could do better. If it's warmer, you do worse. So an example of that would be every classroom taking the PSAT is going to be set at a different temperature. So maybe half of the classrooms are at 75, half of the classrooms are at 65. And that would be more difficult because obviously when you're sitting in a room, you're going to notice if it's hot or if it's cold. So that may not be the best example, but double blind would mean that I don't know what's going on and neither do y'all, but the person that made up the experiment knows. And the reason why they wouldn't come and give the experiment themselves is because there would be bias involved. So the people that make up the experiment don't have any involvement in that. So Hippity Hop rabbit food makes fur soft, shiny, and increases energy for all types of rabbits.
Well, you can't do that.
Can I make this
We
claim?
only know our group. You can't use a sample to talk about the population.
Not yet. Not yet. We can't do that. So we have this thing called a confounding variable. Confounding variable is a variable whose effect on the response cannot be separated or distinguished from the effects of the factor on the response. So this is the word that gets the most confused in this whole unit every single year. So I want to explain it from the beginning, and I want you all to listen because this is so important. This vocab term comes up all the time on tests, and it's like just hard to understand. So confounding variable means when I do this experiment and I find out that hippity hop is better, I have what's called a confounding, I could have what's called a confounding variable. And what that means is when I get my results, I don't know if hippity hop is better or if these bunnies grow because of hippity hop. So bunnies are growing. Whoops. Gonna write this down. So bunnies grow. And I don't know if it is because of the hippity hop food or if it's like, what is something else that could affect growth in a bunny? Age. So it could be because of their age.
Amount of water.
So age is confounding. So age is confounding with hippity hop bunny food. So it is, so a confounding variable is any variable that could possibly affect your results other than what you're trying to test. So what we do is we try to block or we try to stratify by those confounding variables so that we can really see clear results. Does that kind of make sense? So it's any variable that could potentially affect, you don't want to ignore them. No. So a variable that is related to both group membership and the response variable of interest in a research study. So because observational studies may contain confounding variables, their results cannot be used to show cause-effect relationships. So observational studies, everything that we did last class, cannot be cause, no cause-effect. But in an experiment, we can have a cause-effect relationship if we have a well-designed, well-controlled experiment. And you need these principles. So control, randomization, replication, and blocking, which we'll discuss in a later time, in a couple minutes. But you need these three things for sure. This one is a sometimes, case-by-case basis, sometimes. Blocking. So control, you can add that in and then put a little asterisk next to it and say sometimes, like only if needed. So control means that I hold all of the extraneous variables on the response constant. So if you, like if we were talking about the example where we had the temperature in the room. So temp in classroom, that was our example. Then what are some things that we would want to hold constant or that we would try to control that could potentially affect the grades that you make on the test other than the temperature in the classroom?
How much you studied.
Like how much you studied. So we could maybe try to control that. Sleep,
Breakfast.
the noise,
Age. Breakfast.
maybe like the subject of the class or something. Maybe we only want to measure like pre-AP Algebra 2 or AP Stats classes. The teacher, those things.
Disability.
So control means you want to hold extraneous variables constant. So you want to keep as many things the same for all treatment groups. Otherwise they could affect your results, which I call those extraneous variables. So don't get the word extraneous variable and confounding variable confused. So let me explain the difference really quickly. Extraneous variable is anything that could potentially affect your results. You want to hold extraneous variables constant. So hold them constant. That is your goal, is to try to hold as many extraneous variables constant. And you just listed out like 10 of them for me. So you could try to hold all of those constant. That is what control is. Randomization is the use of chance to assign subjects to treatments. So HAT method was one of them. We'll learn a few more in the next chapter. But there must be some form of randomizing. You're not just saying like this half goes to the first group and this half goes to the second group. You have to make sure there's some sort of randomization. The third thing is replication. That was when we talked about how you can't just have one bunny per food. You need multiple bunnies per food, per treatment. Per type of food. You need more than one. You need lots of bunnies. You need lots and lots of bunnies. So many subjects. Because if you just have one, then that wouldn't be accurate. Yes.
Confounding is something that ruins your data.
So whenever I said hold extraneous variables constant, then when we talk about confounding, a confounding variable is like you've already, taken your results, you've already done it.
And then you realize.
realize that this became a confounding variable. Like you didn't, and so later on we're going to talk about how you need to block by confounding variables, which we'll talk about in a minute. Yes.
So it's like extraneous affects your results, and then confounding variable affects like the causation aspect.
So confounding variable is like you've already done the experiment and you've realized that you now have a confounding variable because you didn't control it or you didn't block by it in the first place. So confounding is like it's already happened.
It's like the age thing. It's like so that's gonna be like competing with we don't know what the cause was because.
Right. So we've done our experiment and we maybe did not block by age. So now we get our results and we realize that age was the confounding variable. Okay. The only way to show a cause-effect relationship is with a well-designed, well-controlled experiment. Highlight this slide, circle it, tattoo it on your arm like you.
It's
against the Bible.
Mimi says no. Don't tattoo it on your arm.
Wait, I thought you just.
Just said.
I know, I'm sorry.
Stop lying.
I know. I'm sorry. So, now cause effect is okay if you have well-designed, well-controlled experiment. So you need the 3 principles, which is control, randomization, replication. You need those 3 things and sometimes blocking. So it's like, the vowels, it's like A, E, I, O, U, and sometimes Y. It's like control, randomization, replication, and sometimes blocking.
Wait, why is Y only a vowel sometimes?
That's like why blocking is only sometimes needed in an experiment.
But why is it so?
Wait, when is it a vowel? Give me an example.
When it's like the word
Like
die?
fly, cry.
So when it's not right by that.
Okay, here's an example. We are going to, I think this is the fertilizer activity. So, yes, we're there. So let's turn to page 161. Oops, no.
Is it supposed to be a river? Wait, why are there globes on the trees?
Those are not globes.
Is anybody
Those are
else see
trees.
this?
Those are trees.
That is a globe.
That's a globe.
Stop
That is a
criticizing.
Definitely South America and Africa.
Yeah.
There are globes on the tree. This will help. Look at
Okay, I believe you.
Who did the photo
This
chopping?
is trash.
It's clip art.
This clip
No, I
art
didn't
is
make it.
low,
No,
not first
that's
grade.
legit globes.
All right, so a farm product manufacturer wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizers. 16 similar plots of land are planted with the same type of seed but are fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. So, in my experimental units, those are the who or what is getting the treatment.
Trees.
Plots.
Fertilizer.
The plots of land. Plots of land. What are the factors?
Soil.
The types of fertilizer.
Oh.
Types of fertilizer. So that is kind of like what is the treatment? Factors, treatment, kind of the same thing. So types of fertilizers. Remember, that's like your big umbrella is the factors. How many levels do I have?
2.
3.
3.
Where does
What?
it
Two different
types of
types of
fertilizer?
Why does this PowerPoint say 3?
We have
It's
skewed
stupid.
data.
Hey, you were reading
Is this a different example?
You were reading a different thing than our paragraph.
Six.
Why did none of us tell her?
I don't know.
Because I
Come
just
on,
figured
babe.
that she had.
Is this a different? So maybe this isn't page 161. Maybe we're just supposed to watch.
fertilizer
Are we
activity?
still-
I don't think so.
Oh, wait.
Mini fertilizing activity.
Let's just follow along with this and see where it
Later
goes.
on?
Can we just work
Oh,
with
this
this?
is in
Yeah.
this is in the PowerPoint.
Right, but I think that
The different
it's also goes along with the fertilizer activity as well.
So there are 2
No.
treatments on ours and 3
So
on
there's 2 treatments on yours. There's 3 on this example.
The response variable would be
The response is the yield of crop because that's what I'm going to measure at the end, and then how many treatments. There will be 3 in order. So a lot of times the question will ask you like how many treatments or how many treatment groups. You take factors times levels. So factors times the number of levels.
Oh, ours is
Wait, what's the difference between... Ours said factors dash levels. So what does that
Guys,
mean?
just go to
So you would
PowerPoint.
say 2 factors, or 1 factor, 2 levels. Because you have 1 factor, which is your type of fertilizer. Within that, you have 2 levels. So maybe, like sometimes I've seen examples where they give multiple factors. Like I want to measure, or I want to test like the type of bunny food and the type of fertilizer. Like, I want to test both of those. So I would have 2 factors. Within that, I have 3 bunny foods and I have 4 types of fertilizers.
They don't have to go together?
No, I'm just giving you an example.
So would their distance from the water be confounding or
Well, it depends when you realize this.
Yeah,
You had to
control?
already.
we're going to talk about it in a minute.
Okay.
So suppose that 16 plots of land with globes on them are not similar. Some are close to a river with trees along the bank while others are farther away.
And that's okay.
Oh, now it's just A and B. So it went back to where it started. Suppose the researcher decides to fertilize the 8 plots closest to the river with fertilizer A and the remaining with B. Does he have a greater yield with A? Does this mean that A is a better fertilizer? Why or why not?
No,
Greater
because the
yield
land is
doesn't
closer
mean
to the
it's
plot of water, so it can be.
Other
it can be, like,
variables, not
nutrients.
excuses.
Yeah, so I have extraneous variables like how close or the vicinity to the water that could affect my results. So it would not be a good idea to put all of A there and closest to the water and all of B, because obviously A will probably be better unless it's flooded, then it could be worse, but I would think that it would probably be better to have, or A would end up being better. What's going on? Oh, there we go. Okay, here's another example. So we haven't done fertilizer activity, I guess. I don't know.
What?
We'll get to it in a minute.
Yeah.
We may not get to it. We'll see.
Yeah.
Okay, example 2. A consumer group wants to test cake pans to see which works the best. It will test aluminum, glass, and plastic pans in both gas and electric ovens. So this is where we see the different factors and levels. So what are my experimental units in this example?
Cake pans?
Cake batter, good.
Cake what?
Cake batter. That's what's getting the treatment. Cake batter is getting the treatment. Yes, because it is the one changing. What are my factors?
Cake pans?
I have the type of pan and also the type of oven. So I have 2 factors within that. And those are the 2 things that I'm changing. Then within that, how many levels do I have?
Aluminum,
4,
glass, plastic.
So I have the type of
gas,
pan.
electric. This is a 5?
So I have the type of pan, aluminum, glass, and plastic.
that would
So
be 6.
so 3 levels within that. And then 2 levels within.
There's 10 treatments?
So then, yeah, we'll do that in a second. Response variable, what am I measuring?
How good it gets baked.
Yeah, like how good it gets baked. That's what I'm going to measure at the end.
We don't get
Which
that.
could also seem subjective, but maybe not. I don't know. You bring in some, like, testing experts.
It's still subjective.
I could
Yes,
do
PhD
So
in
then
mechanical
number of
gases.
treatments, you're going to take the number of factors and the number of levels. So I have 3 levels within the first type, and I have 2 levels within the second type. So you end up doing 3 times 2. If you think of every combo, that would be another way, like every single combo. So I could have aluminum with electric, aluminum with gas, glass with electric, glass with gas, plastic, electric, plastic, gas. So if you just list them all out, that's how many treatments or how many treatment groups you'll have. Okay, I might. So I guess this is going back to the fertilizer. It's jumping all over the place. So a farm products manufacturer wants to determine if the yield of crop is different when the soil is treated with the different types of fertilizer. Then we plotted the land. So why is the same type of seed used on all 15 plots? It is part of the controls of the experiment. So whenever we talked about controlling things, maybe the type of seed that was used could be an extraneous variable. So I want to control as many things as possible. So the type of seed that I use is going to be one of those controls, like one of those things that I hold constant. So if every single plot of land is getting the same type of seed, then that means that the type of seed is not going to affect my yield of crop. What are some other potential extraneous variables? We talked about them.
Soil,
Like
amount of
their
water.
the type of soil, amount of water.
Weather.
The weather is a good one, yeah. Does this experiment have a placebo?
Yes.
No.
No,
I think it can.
it can't.
That's what it
It's farm wise.
Yeah, no placebos, because placebo, like the types
Well,
of
what if
soil.
You think something grows better.
Yeah, but my
Isn't that-
That's
placebo
that's not
is
placebo.
put on an experimental unit.
That's-
That's a bias.
No, but
It's
here
like you have a magical spray.
placebo would be like the plot of land thinks they're getting something and they're not. So the plot of land doesn't have a brain to like. It has to be on a person. Yeah. Yes. So there are 3 types of experimental designs, and this is the last part, so we're almost done. There are 3 types of experiments. You have a completely randomized design, where it means that every single experimental unit has the exact same chance of being chosen for a treatment. So I like to compare this to an SRS for observational studies. So we learned about SRS last time. Those are for observational studies. This is like the equivalent or its counterpart for experiments. So that means the experimental units get randomly assigned to either treatment, we measure them, and we compare them. Completely randomized is the easiest one to do. It will always work in any scenario, but sometimes it's not always the best one to use. However, if a AP test said design an experiment, they'll always count a completely randomized design unless they tell you to block first. So completely randomized would mean that I randomly assign them. I could have like numbered all of my plots of soil like 1 through 16 and assigned them. But it would mean that every single plot of land has an equal chance of being A or B. So, yes. So suppose the researcher decides to randomly assign fertilizer A to 8 plots and fertilizer B. He has a greater yield with A. Does this mean that A is better? That A is with the better fertilizer? So, yes.
What if there's like different shades or something?
Yeah.
But since we have control, we have replication, and we have randomization, then we can say that there's a cause-effect relationship. So, yes, the effects of water and soil type are evenly spread into both treatments, so there is no confounding because we evenly assigned or we randomly assigned them to plots of land. Now, if you wanted to see whether you think that it is confounding or not, like if you wanted to get a more accurate data set to see if the type of or the vicinity to the water really does affect it, then we could block. So this is called a randomized block. I would compare this to be like a stratified for observational. So I would compare this to be kind of like a stratified. So observational is stratified. For experiments, it's randomized block. So units are blocked into groups first and then randomly assigned to treatments. One thing that I've seen show up on the AP test that I don't feel like everyone was prepared for, I think it was the first year that I taught, we didn't discuss this as much. You cannot put groups, you cannot put people into blocks after the experiment has been done. So you must block before collecting data. So you can't collect your data and then decide to block after the fact. You must do it before. So experimental units, you have them. You create blocks, homogeneous blocks like stratified. And then you randomly assign. Then you compare within the blocks. So this is the main key. You compare within the blocks. So it would not make sense, like if I were blocking by how close they were to the water, it wouldn't make sense to compare how close they were to the water to not how far away they were from the water. So you only compare within the blocks. And then you compare the overall treatments. You only block by a variable that you think affects the response. So we think that the vicinity to the water affects my response.
So what do you mean by like compare within the blocks.
So if I split my, we're going to see in a minute, I'm going to split them into 8 blocks and 8 blocks, like close to the water, further away from the water. I'm only going to compare within those eight types of soil. Okay, we'll see that in a minute. So the purpose of blocking is to negate the potential for a confounding variable and reduce variation, but some also use it for bias reduction in voluntary samples. Reduce variation, remember when we did the jelly blubber activity and for stratified, everyone got a pretty similar answer? That's kind of the same thing for blocking here. So you don't want answers all over the board. You want to try to reduce variability, so blocking will help do that. So here we're going to split them into 2 groups. We're going to block by the closest of the water. And so we're going to split them into groups of 8, then randomly assign within those. So now we get a more even spread.
That had to be homogeneous.
They are. So those first 2 columns we say are like closest to the water. The second 2 columns are further away to the water. So we're blocking. Yeah.
Okay.
So we just put them in 2 blocks. So blocking is a way to control the effects of extraneous variables so that you don't have, so it reduces the potential to have a confounding variable is what it's doing. Does that kind of make sense? So blocking just kind of makes sure that I'm not going to have a confounding variable in the end. Otherwise, when you do an experiment and you don't block, you may get a confounding variable. Okay, the last one is matched pairs. It is a special type of block design. Matched pairs is the same thing as blocking, but you're putting them in pairs instead. So we match up an experimental unit according to similar characteristics, then randomly assign one to one treatment and the other to the other one. Or, so there's 2 types. You either do pairs of people or pairs of things, or you have one person that gets both treatments. So there's 2 ways. There's 2 types of matched pairs. In this example, we would just take 2 plots of land that are the closest to each other. One would get A and one would get B. But a lot of times I see like before-after scenarios. So maybe like if I'm trying to measure weight loss, then I give them one treatment and then I measure the weight. Then the same person does another weight loss treatment, measure their weight. And the reason why this is the most important to do matched pairs with something like this is because every person's body is different, so they're going to react to medicine or to supplements differently. So that's why doing a matched pair on this type of thing would be better. So one person gets both treatments. The assignment for treatments is dependent. I don't know what this is. What's happening?
They're putting the places together.
So I guess it's giving us the process of an experiment. I don't remember this. So, okay, so this is a match pairs illustration. This is what's happening. So we put them by similar characteristics. They all are like different emoji faces. Then randomly assign one unit to A and the other to B. There we go.
It's a lot of work.
I know.
to make this up.
There we go. So you put the 2 closest people that are the closest in a characteristic. So maybe I think like weight affects your heart rate or something like that. And so if I'm trying to test whether exercise affects your weight loss, then I'm going to pair people by the 2 closest people in weight or something like that. Then I would put those people, one would go to treatment A, one would go to treatment B. And then, so that was one way to do it. And then the other way is to have an individual do both treatments. Maybe like a taste test. I've seen like a before and after scenario, things like that. So remember us seeing these on the last unit. Did we talk about these last time? Where it was like a causes.
Nothing can lower IQ. Right?
Smacking his IQ.
You can-
So these were all different articles kind of over the same type of study. So in this study, 2 groups of children were followed for 4 years. So that's a longitudinal study. I mean, this is for a long time, 4 years. 806 children, ages 2 to 4. and then 704 children ages 5 to 9. IQ was measured at the beginning of the study and again 4 years later. So that would be a matched pairs, because why?
Because they're the same age.
Like I'm giving them, well, I'm doing it twice, I guess. So I'm doing a before and then I'm doing an after scenario. So the IQ was measured at the beginning of the study and again 4 years later. This is a study, it's not even an experiment. So they're not actually even doing anything. So study IQ was measured at the beginning and then again 4 years later. Researchers found that the average IQ of the children ages 2 to 4 who were not spanked was 5 points higher than those who were spanked, and 2 points higher for children ages 5 to 9.
Don't spank your children.
So these headlines imply, this is why we shouldn't read things. I'm just kidding. That's why we shouldn't believe everything that we read. Because these headlines imply that spanking is the cause of the observed difference in IQ. Is this reasonable?
No, they probably watched too much SpongeBob or something.
They probably watched too much SpongeBob. So does spanking cause? No. The reason why is because this is an observational study. So first of all, anything with an observational study means that nothing causes the other to happen. I would have to do an experiment where I guess I put them in two groups and I say, parents, you spank your children, and then the other parents, you don't spank your children, and then let's see what happens. That would be unethical. So we wouldn't do that in the first place. So this really has no bearing at all. So now you're going to be able to be more aware about what you read in the news and things like that.
Like application.
Are there other variables
Big news.
connected to the response and the groups of children? So why would maybe a child decrease in IQ other than spanking?
Drug
It's
use.
not smart.
Drug use.
Drug use, concussions.
I feel
Ooh,
Are there
that's
things
so
connected
hard.
with
Lack of love and
spanking?
tenderness.
Alcohol.
Neglect.
Like, you know, if kids are getting spanked at home, that probably means that there's other issues. Yeah, like they have bad
healthy or
behavior.
bad diets.
That they're eating too many Cheetos, maybe? Is that it?
Online chat
Healthy or
rooms.
bad?
Online chat rooms at the age of 5.
Healthy or bad? Oh.
Oh, it's like a healthy
So that's
or
what I
bad.
would call a confounding variable. I don't know what's going on now.
Oh my gosh.
Have you looked at this?
Something-
PowerPoint?
I have. I just forgot.
She is prepared for class today.
I'm going to be honest.
Grady-
I just looked at it and I said,
Grady's
Too much
again.
time
it's been a
baking.
year. It's been a year. I haven't
Too
seen
much
it.
time baking cookies and not enough time baking up this.
Exactly, when was this
lesson.
PowerPoint made?
I don't know.
Someone had
A while
so
back,
much
Kathy
time on their
Fritz.
hands that they just like made all
Like,
these
this is
versions of it.
unnecessary.
I don't know. I don't know what's happening. It's just
And that one
going.
disappeared.
Concerning to
That
me.
one did not go anywhere. That just disappeared. I promise.
I saw
Yes.
do that too.
Confounding does not occur in a completely randomized design. That's all I needed you to get out of that. I needed you to get that out of the slide.
That's what I got.
Confounding does not occur in a completely randomized design. So when you completely randomize, that takes care of all confounding variables. So let me explain that. Let's take the classroom and temperature example, because I like that example. If I took 100 students at PCA and I put them in different classrooms to take the same test, what are some things that affect, when we talked about this, what are some things that affect your grade on a test besides the temperature in the classroom?
How much you studied?
How much
How
you
smart
studied.
you are.
So when I how smart you are, like what grade you have in the class. So when I completely randomize you, I assume that I'm evening out all of those confounding variables. So I'm going to get some smart kids and some dumb kids in every classroom. I'm going to get some kids that studied and some kids that didn't study in each classroom. So that randomization is evening out your playing field in every single classroom. Does that kind of make sense? I'm going to have a little bit of everything in the classroom by
A
randomization.
little bit of people playing the guitar.
A little bit of, yes, a little bit of that. Okay, an article from USA Today reports the number of victims of violent crimes per 1,000 people. 51 victims have never been married, 42 are divorced or separated, 13 are married, and 8 are widowed.
Oh my.
Is this an experiment, yes or no?
No.
No, it's just reporting facts.
It's just fact.
We didn't have any
Or,
treatments.
no,
There was no treatment involved. We were just gathering data.
Why is it imposed? It sounds like it's like.
Impose meaning like I'm making you do something. Like I'm imposing a treatment on you. That's just that's just the verbiage that you use. Yeah.
She's checking, she's making us.
Yes. What is a potential confounding variable?
Their mood.
Could be age.
What race?
That's it.
Type of diet.
Type of diet? Probably not.
Race.
Why is it always got to be about race?
Their religion.
Is it not?
It could be.
Race is the most important thing.
Next
Race is
one.
definitely a
Brooks is
factor.
caught up.
4 new word processing programs are to be compared by measuring the speed with which standard tasks can be completed.
Very simple.
100 volunteers are randomly assigned keywords to one of the 4 programs, and
Yes.
their speeds are measured. Is this an experiment?
Yes.
No.
Yes.
Yes, but it's not good.
Random.
Assign.
And
Assign.
there's no
Yes.
confounding.
It is because they're
Let's say you
forced.
read something and you don't know. Randomly assigned tells me experiment. If it says randomly selected, then that means observational. So assigned is experiment, selected. Yes, a treatment is imposed. Okay, what type of design is this?
It's
Out of the 3 we learned, completely randomized block or match pair.
random.
Completely randomized, yes. What's my
The
factor?
4 programs.
The type of program.
Force. Yes, I mean.
And then we have 4 levels within that. So there's 4 programs, but the program itself would be the factor, 4 levels. What am I measuring?
Speed.
Speed.
Speed of
Program.
standard tests completed.
Good.
Nice.
That's for the points. Is there a potential confounding variable here?
No, it's random.
No, it's random.
Randomization minimizes.
Yay!
Confoundation.
You got it.
Confoundation.
Confoundation.
Build a strong confoundation.
We don't have to write that one.
Could it be improved?
Yes, they could be taught the program ahead of time.
That's stupid data.
No.
If you don't know how to use the program, you're obviously going to be slower.
No, it's like if you click on a button, how long does it take for the program to respond?
Oh, I thought it was like
Better Wi-Fi.
We could do a block design where each person, so we could do a match pairs where every person does every program. Like does all 4 programs and then compares each person. Because everyone in here has a different typing
But then you have the
speed.
confounding variable.
Everyone, like I probably type faster than all of y'all. So if
Excuse
I
I've always had to
Granny.
type 100 words per minute, baby.
Yeah.
I'm
Mimi
not
knows how to
Yeah.
type,
I can
okay?
do
You don't even know what a computer is.
Mimi's got arthritis.
Mimi.
Take the book, dude.
My fingers are shaking.
You knit and you read. That's all you do. And bake.
I need my vitamins.
That's so stereotypical. I'm a cool grandma.
We stereotyping
Prove it.
you. You always said it.
We were generalizing you.
You are. We gotta watch time for the lockdown, Charles.
Oh, yeah.
Is this PowerPoint almost over?
Well,
You tell me. Have you looked
Wait,
at it yet?
can you?
What know about the lockdown drill, Mimi?
Mimi knows that
Okay,
it's what
there's
140.
Mimi could take
Okay.
anyone.
Okay, next one. Suppose that the manufacturer wants to test a new fertilizer. What? Drew, you have to stop. You have to.
No.
You have to stop.
You don't even know what this PowerPoint's about.
Finally.
Suppose the manufacturer wants to test a new fertilizer against the current one on the market. Why is everything about fertilizer?
How do you do that?
10 plots of land scattered throughout the county are used. Each plot is subdivided into 2 subplots. That's interesting. One of which is treated with a current, the other with a new. What is planted? Wheat is planted and the crop yields are measured. What type of design is
Randomized
this?
block.
Match pairs.
pairs.
Why is it match pairs and not randomized block?
Because they're subdivided.
Yeah.
Because it's
They're
math.
subdivided into pairs.
I knew that.
When does randomization occur? The randomly assigned treatment to the first acre in each 2-acre plot. So when I had the pairs, I randomly assigned the first one. That was the randomization. Randomization, these are things I would want to highlight and memorize, but they're also on a page it might be right after this PowerPoint, and it says like common mistakes.
Right?
You see a page that says common mistakes.
Vocabulary.
After vocab.
Three pages later.
Like what does this do?
Wait,
Yes.
What does that do?
You need to know that whole page. What page is it?
155.
Yeah, this.
Page 155.
Wait, what?
Get it together. You have to know all that as well.
Oh.
This test is going to be lengthy.
So randomization reduces bias by spreading any uncontrolled confounding variables evenly. So that's when I talked about the people in the class, the temperature in the classroom. It's randomly spreading out ability level. It's randomly spreading out the people that studied and didn't study. Randomization takes care of all of that. It reduces bias. It never eliminates bias. It does not eliminate. So,
To absolutely.
not eliminate. Don't ever choose something that says eliminate because it's just impossible to do. Bias is a systematic error. We talked about that. Blocking helps reduce variability. So remember, think about blocking as stratified. Stratified has small variability, small range. So think about it that way. Is there another way to reduce variability? Blocking is used to counteract a biased sample. And variability is controlled by sample size. Larger sample sizes have less variability, so they're an inverse relationship with each other. The larger the sample, the less variability I get.
So what time does drill time do?
140.
In 4 minutes.
Go down.
So here's kind of a visual of what variability and bias look like, where the center is kind of like the data that is unbiased. The outsides are the biased part, if you're thinking about it in terms of like a dartboard or something. So high bias, high variability, high bias, low variability, low bias, high variability, low bias. So this low bias, low variability is what you want. That's the end goal. And you get that by randomization and blocking. So all of the principles of an experiment: randomization, replication, control, and sometimes blocking. In the end,